This is a video demonstration for refraction experiments option 2. Firstly, the materials that we will require. We will require a plastic transparent container. For this experiment, it is better to have a container where the plastic is as thin as possible and the width of the container is also as small as possible because the plastic will interfere in our experiment a little bit, but the thinness of the width and the plastic will make sure it does that as little as possible. Next, we will require some stationary items like a ruler and a pencil, and we will require 4 pins. We can use any kind of pins or needles, just anything that we can use to mark position with on the paper, and of course we'll require a sheet of paper. Now beneath this sheet of paper I have a cardboard because my table is made of glass, so I can't actually stick the pins into the paper so that they will stay there, so that's why I have a cardboard underneath this sheet of paper. The first step is to draw 2 perpendicular lines on our sheet of paper. One of these lines is going to act as our normal line against which we are going to measure our angle of incidence and our angle of refraction. Now, it's hard to make perpendicular lines without a protractor, so just do it as accurately as you can using trigonometry. In the video, I'm incorrectly referring to one of the lines as the principal axis. It is in fact not the principal axis, but the normal line to the container, to the surface of the container, which I'm going to mark in one of the next steps. The next step is to make the angle of refraction. So for this experiment, I'm using a 45-degree angle because it is the easiest to make without a protractor. Basically, you just measure equal lengths on both the normal line and the other perpendicular line, and just use right triangles in trigonometry, and join the center of the perpendicular lines, the point of intersection of the perpendicular lines, with the point that is 4 centimeters from both the normal and the other line, and that would give you a 45-degree angle against the normal. So that will act as our angle of incidence. That will indicate at what angle the light is going to enter our plastic container. The next step is to draw the boundary of our plastic container. So I'm just going to place the container on the paper and use the pencil to draw around it, and it will mark the boundary. This is important because it will tell us at which point the light will enter the container and at which point it leaves the container. So those things are important for us to note. This is the boundary that I have marked on the paper. Next, I am going to use the pins and mark the position of the light with those pins. I'm going to use 2 pins and place them on the line that forms the 45-degree angle with the normal line, as I've indicated in the video. So just going to use a pin to do that. This is a bit difficult to do with this, so this is a bit difficult to do, while taking care of the camera, so I'm just going to fast forward to when I've attached the 2 pins in a line. So this is how the setup looks right now, where the pins indicate the light that is entering the container. Next, we're going to add some water in the container and observe how the image of the pins has broken and shifted, and basically what we're trying to do here is mark the position of the image of the pins when it leaves the container. So for this purpose, we are going to move our line of sight in such a way that the image of the pins appears to be in a line when they're viewed from the container. So just going to move the camera a little, and as you can see here, the pins now appear to be in a line, and this is where we will place the other 2 pins in order to mark the position of the image of these pins. So I'm just going to use pin 2 and place it exactly at this position. This bit is a little bit difficult to do while holding the camera, so I'm just going to fast forward and show you. how it looks when I have placed two pins such as they appear to be in a line with the image that is coming out of the transparent container. As you can see, when I move my camera, the image breaks apart again, but at a certain point, they appear to be in line with each other, as you can see here. Now, this is the angle. This is the position. These images tell us the position of the image as it emerges out of the container. So when we have removed all the apparatus, in the next step, we have removed all the apparatus, we will mark the position of the pins with our pencil and join these two pins to the surface of the container, and then take that point and join it to the point of intersection of the perpendicular lines. Now that the angle that line makes with a normal line is the angle of refraction, and it will tell us what the refractive index of water is. We will use the angle of refraction and the angle of incidence in the equation for Snell's law to give us the refractive index of water. This is the end of the demonstration. Good luck.